Lesson 14.3 is solving quadratic inequalities. And the first step we want to do when we solve an inequality is to change the inequality into an equation. Now with any quadratic equation to solve, I want to set the equation equal to 0. So I'm going to add 12 to both sides. Next, I'm going to factor the left side. Then I'm going to solve. Then I'm going to set up a number line. Now, because my inequality is less than and not less than or equal to, what I do know for sure is I'm going to have two open circles. Now I need to determine what portion of the inequality, what portion of the number line I'm going to shade. So I need to test various numbers along the number line. And I'm going to begin with testing it with the number in between -5 and -2. I'm going to select the number -3. And so I'm going to go back to my original equation, take out each x value, and replace x value with -3. What I'm trying to determine is if -3 is a solution, if -3 is indeed a solution, then I'm going to choose the values that are between -5 and -2. So that's what I'm testing to determine. Now, you need to decide, is -14 less than -12? I'm thinking on the number line, yes, -14 is to the left, and therefore is less than -12. So this point right here, -3, is a solution to this inequality. So what that means is the graph of this inequality would include all the numbers between -5 and -2. Now it's always a good idea to check a value to the left of -5 and to check a value to the right of -2, just to make sure. But I feel very assured that this inequality would represent all the x values that are greater than -5, but less than -2. In interval notation, we write that as -5, comma, -2. Now, I know this looks like an ordered pair, but in this particular situation, it's actually an inequality that's written in interval notation. And the way that we show that is we say x is an element up. So that we know, therefore, then it's not an ordered pair, it is the solution set to this inequality. Number 4, I'm going to begin by setting this equation equal to set this inequality as an equation. For this equation, I'm going to use the quadratic formula. And the reason why I'm going to use the quadratic formula is I'm looking at this and it doesn't appear to be factorable. It's not conducive for completing the square. options here are to go ahead and use the quadratic formula. So I'm going to place negative 8.2 further to the left, positive 2.8 furthest to the right. My inequality began with a less than or equal to, which means I'm going to have closed circles, closed circles. And I'm looking at a value in between that would be easy to plug in. And it looks to me like if I plug in the value of 0, 0 would be a good choice. So I'm going to go back to my original, my very first equation, and I'm going to take out x and put in 0. That gives me 0. Plus 0 minus 21 is less than or equal to 2. And what I noticed is when I transferred my answer from my graphing calculator, which was positive 8.2, I made a mistake and put a negative 8.2. So we need to go back and make a slight adjustment. All right, so let's switch these numbers around. Let's put 2.8 here and 8.2 at this end. And so I'm going to need to select something other than 0. All right, we'll have to try this again. Although 0 could definitely help me to determine if this side of the number line satisfies the inequality. So if I go back, I remember I had 0 plus 0 minus 22 is less than or equal to 2, and that's a true statement. So yes, this portion of the graph satisfies the inequality. So my guess now is that this would be the other portion that satisfies the inequality. And so I'm going to select the number 10, which is greater than 8.2, and come back up here and replace x with the value of 10. I replace with the number 10, which is to the right of 8.2, that number 10 also satisfied this inequality. So my solution set is all values less than or equal to 2.8, or all x values greater than or equal to 8.2. In interval notation, that would be from negative infinity up to and including 2.8, or at 8.2 through infinity. Number 6, negative 50 is a rational number. It's a complex number. It is an integer. It is also a real number. Number 8, square root of 15 is an irrational number. It is a complex number. It is also a real number. Number 10, the square root of 25 is equal to 5. Therefore, natural number, rational number, whole number, complex number, integer, and real number. Number 12, the square root of negative 20 can be factored into the square root of 4 times the square root of 5 times the square root of negative 1. The square root of 4 is 2. The square root of negative 1 is I times radical 5. Number 14, the square root of negative 144 can be written as the square root of positive 144 times the square root of negative 1. And the square root of 144 is 12. The square root of negative 1 is I. All right, let me give you a moment to read through number 16 to analyze the scenario and situation in this problem. If you need a little more time, go ahead and pause the video to read this through thoroughly. So it looks like you're launching a pumpkin, and the pumpkin is going to travel the path of a parabolic curve. My pumpkin is starting 2 feet off the ground. Travel up, and it's going to come back down. However, my pumpkin doesn't reach all the way to the ground. It's going to stop before it reaches the ground, and it's going to land on a platform that's 10 feet above the ground. So let's take a look at what it would do if it didn't land on the platform. So what tree, right down the middle here, where I have my vertex, is going to reach a height of 300 feet, and that's taking place after 5.5 seconds. So starting with time in terms of seconds, we have height in terms of feet, and launching at 0 seconds. Halfway through, I'm at 5.5 seconds at its maximum, which means it would take 11 seconds for the pumpkin to come back and hit the ground. 5.5 is exactly halfway through the path of the pumpkin. So 5.5 times 2 gives me a landing time of 11 seconds. So if this pumpkin is actually landing on a platform that's 10 feet off the ground, 10 feet off the ground would be right here, it has to land there in less than 11 seconds. So how long will the pumpkin be in the air? I'm going to go with choice A, which is less than 11 seconds.